All right, now here we are with an exploration of slope, point slope, and slope intercept form with me, Mr. Haynes. So for the first part of this video, we're going to let this essential question guide us. What does the slope of a line tell me about the line? Interesting. What does the slope tell you about the line? All right, so let's take a look at what this is talking about. So what is slope? The slope of a line is actually just connecting the dots in 2 points on a coordinate plane. So we can refer to the first set as x1, y1, and the second set as x2, y2. I can change these points any way that I want as long as I'm making sure that both points are either 1s or 2s. And the slope of a line, in this case, the slope is positive because from left to right, the line is rising. And the slope itself is the change in y over the change in x. So it's the rise of the line over the run of the line. So there's lots of information here. And the big piece is that it's telling us where the denominator is not equal to 0. And then something that a lot of students have always asked me about, like why is it m? Why is the slope of a line m? And that's because it's common to let the letter m represent the slope of the line, because m is the French verb monter. I don't think I pronounced that correctly, which means to rise or to ascend. So what is slope? It's the steepness of the line, and it's positive or negative if it goes up from left to right, or down from left to right, it would be negative. All right, awesome. Lots of stuff with slope here. I see a formula. Let's use that formula. So we're going to find the slope of a line here in example 1. I'm going to use the first 2 points. What I like to do is I like to just write them out horizontally so I can visually connect the y's and then the x's. That helps reinforce in my mind where to substitute them into when I'm using the slope formula. So the top I connect the y's and the y's are on the top, and the bottom I connect the x's and the x's are on the bottom. Awesome. So then 1 minus 4 is -5, and -3 plus 2, of course, is -1. 2 negatives make a positive. My slope is positive 5. Sweet. All right, so let's take a look at B. For B, I'm going to write them horizontally again. I'm going to connect the y's on top and then the x's on the bottom. That again helps me remember what goes in the top of my slope equation and what goes in the bottom of my slope equation. I'm going to solve here. So I have 4 plus 2 and -3 minus 2. That's 6 over -5, and my slope is -6/5. Awesome. So here's your first checkpoint, ladies and gentlemen. Pause the video. I'll be here when you get back. No, there's no answers, but you can have some practice. Solve them the same way that I did. Use the slope formula to find the slope of those 2 lines. And we're back. So let's find the slope of another couple of parallel lines. So let's look a little deeper. So first I've got 5, 4, and 3, 4 written horizontally, connecting the tops and the bottoms, the y's on the top, the x's on the bottom. My slope here is 4 minus 4 and 5 minus 3, but this is weird. 4 minus 4 is definitely 0. So what this means, because we're asking are these horizontal or vertical lines, is that the vertical change is 0. And there's only one kind of line whose vertical change is 0. It's horizontal. So spoiler alert, since we're talking about horizontal and vertical, example B or 2B is probably going to be vertical. So let's see what that looks like. Written horizontally and connected, I'm going to substitute into the slope formula. And I can see immediately in the denominator, that denominator will equal 0. That's like saying its horizontal change is 0. And if a horizontal change is 0, that means that the only thing that line could be is a vertical line. Awesome. So here's your next checkpoint. Go ahead and find the slope of those 2 points. No, the answer's not in the video, but you can do them exactly the way that I did. And remember, horizontal lines have 0 in the numerator, and vertical lines have 0 in the denominator when it comes to their slopes. So pause the video. I'll be here when you get back. And we're back with parallel lines. So let's take a look at example 3. So we're going to show the line passing through the first set of points, 1, 4, and 3, 2, which I have set up right here, is parallel to the line passing through these 2 points. So parallel lines, what does that mean for slope? Let's take a look. So I'm going to put them into the slope formula. And as I solve, I see that my slope here is -1. I'm going to take the second set of points, 2, 8, and 4, 6, put them into my slope formula, I see that the slopes are the same. And if the slope of the line is the same, that means the steepness of the line is the same, and they've got to be parallel. So parallel lines have the same slope. Sweet. So go ahead and try checkpoint 3 on your own and see if that set of points has create two parallel lines. I'll be here when you get back after you pause the video. All right, so of course the opposite of parallel is perpendicular, which makes a giant plus sign, and you can rotate that plus sign around. So two lines that intersect to form 90-degree angles. I'm going to plug these into my slope formula. Take the first one. All right, -9 and 6, and -6 and 3. As I'm solving, I see that I have a slope of 5/3. So I'm going to take the second set of points. I have -8 minus 1 and 10 minus -5. And as you see me solve, I see I get -9 over 15, which reduces to -3/5. Okay, so this is different than parallel lines. In fact, if you take a look at these two slopes, you'll see that the bottom slope is actually the reciprocal. So instead of 5/3, it's 3/5, and it's the opposite sign. So if the two slopes are opposite reciprocals, then that means they are perpendicular lines. So go ahead and pause the video and try checkpoint 4 and see if those set of points create perpendicular lines. I'll be here when you get back after you pause the video. All right, so that was a quick exploration of slope, and now let's dive right into slope-intercept form. All right, so how can I use the slope-intercept form of an equation? We're going to use it in a couple of different ways here. So the first thing is what is finding the slope and the y-intercept from the slope-intercept form, which is right up here, y equals mx plus b. Oh, we're going to reach all the way back and remember this from elementary and middle school. So this equation, as it's written, if it's solved like this, the m is my slope and the b is my y-intercept. So let's take a look. For my first example A, it's already solved for me. My slope is 2 and my y-intercept is -4. I think b might be the same way. It's already y equals, so the slope is 1/2 and the y-intercept is 2. So if we look at c, I've got to do some work. It's not y equals. So I'm going to subtract 5x from each side, and this is where things get a little bit interesting. So the reason I put -5x plus 4, this 4 is constant, it has no x, can't combine them. The reason I have the -5x in front of the +4 and not behind it is because I want it to be in slope-intercept form. So I want my x to be before my constant term. So my x and coefficient are before my constant term, and now that it's this way, my slope is -5, and my y-intercept is 4. So go ahead and try the examples in checkpoint 1 for this section on your own, and I'll be here when you get back. Okay, so we're going to show graphing. So graphing is the most common application for using the slope-intercept form, and it's fairly simple to graph. You got to follow some steps, just 3 steps, and I got you. First step, let's take a look at example 2. My equation, my y-intercept is -3, so I'm always going to start with my y-intercept. My y-axis is vertical, and I've counted from the origin down 1, 2, 3. So my y-intercept is -3. So the next thing I'm going to do is I'm going to use my slope. And so my slope in this case is +4. I'm going to make it a fraction, so 4 over 1. So from the first dot, which is my y-intercept, I count 1, 2, 3, 4 up, and then 1 over. Again, rise over run. Excellent. This gives me what I need to graph the line. I just connect those 2 dots. Sorry about my happy little pen mark. Sweet. So let's do the same thing for example 3, where the only difference is that it already is a fraction for my slope. So start with my y-intercept, +2 on my y-axis, right here. Then I'm going to count up 2 over 3. 1, 2, 1, 2, 3, because my slope is +2 over 3. And connect those dots. So I've got my line, the graph of the line y equals 2x plus 2, or 2/3 x plus 2. Awesome. So step by step, if you've got graph paper, awesome. If not, then you can kind of freehand these. They're pretty simple. Do checkpoint 2 and 3, and I'll be here when you get back. All right, so let's dive into our final topic, which is the point-slope equation. So if I'm looking at the point-slope equation, how does the slope-intercept form of a line help me understand the point-slope equation of a line? So point-slope equation is a different type of equation for a line, and it looks like this. Y minus y1 equals m times the quantity x minus x1. This is really useful when the information, like in example 1, is presented as a slope and a point. So a slope 4 that passes with a point -1, 3. All right, so I can do this. All I have to do is substitute what I know into the point slope formula. In my point, I'm going to label -1 as x1 and 3 as my y1. And I'm just going to put those into the equation. So you see, instead of y1, I put 3 for my y1. And instead of x1, I put -1 for x1. So now I'm just going to simplify a little bit. And right here you see I just, two negatives make this a positive. So I have y minus 3 is equal to 4 times the quantity x plus 1. And that is the point slope form. Now I'm going to extend this a little bit. This is the correct answer to example 1. But what I want to do is I want to see if I can change this into slope-intercept form. And I can. I'm just going to distribute the 4. So 4 times x is 4x and 4 times 1 is 4. And then I can just move the 3, and boom, this is y-intercept form. So there you can see that the two equations will absolutely give you the same line. For me personally, it's easier to graph with y-intercept. It's just my practice and preferred method. But you can graph an equation of a line in point slope because it gives you a point, 1 comma -3, and the slope, and then you can just count the slope from that point. All right. So go ahead and try checkpoint 1, get it to point slope, which is right here in the purple, labeled in black. And if you want to extend it to y-intercept, you can too. I'll be here when you get back. All right, so a lot of stuff is going to be happening here, and we're going to write the equation of a line that passes through these 2 points. So we're going to write it in point slope and then in slope-intercept form. So buckle up, people. First, I have 2 points, so I got to find slope. This is like tying everything all together. So I'm connecting my y's and my x's, and of course now I've got my equation for slope, and as I'm simplifying, I see that my slope is -3/2. All right, so now I got my slope, and this fraction lets me know that I need something divisible by 2. So I'm going to use my first point. You'll get the same equation for the second point. Your point slope form might be different, but your slope intercept form will always be the same. So if you use 4 comma -3, you're going to get a slightly different point slope or form, but it'll still yield the exact same slope intercept form. Okay, so let's use these in our point slope equation. If I can get that out, and I've labeled my points and substituted them in. I see these 2 negatives here. It makes a positive. And now I'm just going to distribute. So as I distribute, I realize I'm going to have to multiply -3/2 times +2. So I make the fraction. I see I can cross cancel, and that gives me 3. Okay, cool. This right here in the red is point slope. But as I'm simplifying further, you see that I'm actually going to add the 6, and now I have slope, y-intercept form. So we have our 2 answers, and we used our slope. Awesome. I know that's a lot to digest. Rewind me. I'm happy every single time I do this. It's not a big deal. Go ahead and do checkpoint 2 to check your understanding. The answer isn't given, but do it the exact same way we did example 2. And that's it. So, ladies and gentlemen, until next time, keep doing the math.